I welcome you all to the Spark Research YouTube channel. This is Dr. Chandra, Assistant Professor in the Department of ECE. Here we are going to continue in this series Analog and Digital Communication. Course code is 21ECC302T, and in this session we are going to take the contents from the unit second. So if you will see the unit second, it primarily being the consider about the two topics, that is your transmitter and receiver. So we will talk about the both type of transmitter like amplitude modulation and frequency modulation, and same the receivers for both types of the modulations, right? So here is your syllabus for this particular unit. EM transmitter, that is we will see the low level, high level levels, then FM transmit, direct indirect method, characteristic of functions of a receiver, AM superheterodyne receiver and FM superheterodyne receiver, noise in AM and FM, elementary and treatment, need for the pre-emphasis and de-emphasis, right? So in this session we are going to consider these topics. Remaining we will cover in the another session, right? So question number one, what is the AM transmitter? Like we know that what is the AM signal, right? Amplitude modulated signal we know. Then what is the difference in between the amplitude modulation signal and amplitude AM transmitter? So the primary difference is, like whenever we are talking about the amplitude modulation only, then we have the information, right? And which we can modulate with the help of the carrier signal. But now question is that how we will send this modulated signal to longer distance. So that is the challenge. So modulation is okay, and if you will modulate and if you will try to transmit, again it may transmit to the very less distance because of the power only, right? So the our objective is to enhance its power so that it can travel to longer distance. So this is the primary difference in between modulated amplitude modulated signal and amplitude transmitter, right? So this is one of the example of the amplitude modulation transmitter. So the transmitter not only perform the modulation process means we are going to modulate our message signal into a carrier, but also raises the power level of a modulated signal, right? So that it can transmit. So there are two categories. One is low level modulation and high level modulations, right? So low level is being done at input side in the beginning itself, and high level at the end. So low level amplitude modulated transmitter perform the process of modulation near the beginning of the transmitter, and high level transmitter perform the modulation step at the last final stage, right? So of course you need amplifier to perform this high level and low level modulation. Clear? So let's talk some more things about the low level amplitude modulated transmitter. So low level modulation takes place at a low power level, and signal is then amplified by class B power amplifier, right? So here class B type of amplifier is being used. Now here you can see this is your voice signal, that is your modulated signal, message signal itself, right? Then modulating amplifier, here itself we are amplifying, right? Then here is your oscillator, buffer, amplifier and harmonic generator. And so here is modulated amplifier class C, right? And so finally class B tuned amplifier is here, that will amplify your message modulated signal, here modulated amplifier. So after that, and then further you can transmit using the antenna to your airspace, right? So this is the block diagram for your low level modulation transmitter. How is it working? So its working principle is almost same except from the amplification, because the almost same as amplitude modulation, right? Because this is the nothing, this is just the adding amplitude modulation and plus one amplifier, nothing else. So working principle, like message signal generated by a microphone or audio, source, then amplified using an audio frequency AF, and carrier oscillator is being used to generate the different type of the signal, right? Master oscillator, different types of the frequency signals, that is carrier wave. And then your modulator means your ST is equal to AC 1 plus of KMT equal to cos omega CT. So here we are adding both carrier signal into the message signal. So this is your modulated wave finally. So this one we are going to send by the transmitter, right? So RF power amplifier is being used here to increase the power of the AM signal, and then merge to the linear class A or class B to avoid the distortion, and then antenna which will radiate to the AM signal to the space, right? So this is the how your AM, low level AM, is working. Now another one is your high level modulation. So here you can see this is your massive signal and a power amplifier, and the RF power amplifier is here. So this is your oscillator. Here you can generate the different types of the frequency, and then you can generate the high power audio amplifier here, so that it will amplify your modulated message and then you can transmit to the antenna, right? So nothing is there. So your carrier oscillator is there, very simple application. RF power amplifier, so here we are using the class C, so that its efficiency will be higher compared to the class B, right? And AF power amplifier using audio frequency, RF radio frequency we are using, and high level modulator also, which will varies the DC voltage to the RF power amplifier. This causes the carrier amplitude to vary in accordance with the masses, right? So output M amplitude modulation signal, clear? So the primary objective is of your transmitter is to amplify the masses modulated signal. So modulated signal plus amplifier is called transmitter, right? Now super heterodyne receiver. So here amplitude modulation, super heterodyne receiver. Now we are going to talk about the receiver side, right? In transmitter side, what is the main major crux? Major thing is that your amplitude modulated signal and plus amplification, so that is called transmitter. Now question is that how will detect? So definitely demodulation, with the help of demodulation we will detect, but exactly demodulation itself is not a sufficient, right? So again we have to amplify our demodulated signal. So again demodulation plus amplifier again, right? That will called as a receiver, right? So here is your antenna which will detect your information, or the modulated signal which you have transmitted through an antenna. And now this is your RF amplifier with band pass filter tunable to desired omega c. So this will the one type of filter which will detect the information only having the frequencies in the range of omega c, right? RF amplifier. And then after detecting, you can create with the help of the local oscillator. So your frequency converter mixer is there, then with the help of that you can convert your frequency. And how will you do exactly? Your IF amplifier is there, that is your and how will you how will you find out that IF frequency? So IF of RF minus FLO, local oscillator, image frequency, and IF and radio frequency, right? And then after that you can detect the demodulation, and then you can detect, and then after demodulating you can amplify your signal, and then finally a speaker will amplify, right? So this is the process here. So RF is basically a tunable filter, right? And amplifier that picks up the desired station by tuning the filter to right frequency band. So next station, the frequency translate the carrier from omega c to IF, right? IF is your image frequency which can be calculated equal to modulus of f of RF minus f of LO. In generally the IF frequency is fixed, right? And what is the value? That is 455 kilohertz. This is valid only for AM super heterodyne receiver, right? Amplitude modulation super heterodyne, this 444 kilohertz, right? For this purpose, it uses a local oscillator. How will you exactly now will you convert? So that is why we are using local oscillator, right? So and incoming the frequency, that is fc. So FLO will be f of c and plus f of if, right? So carrier frequency, you have to add that particular frequency so that it will give you the image frequency. Note that this is up conversion. The tuning of the local oscillator and the RF filter is done by the knob. And so tuning capacitor in both circuits are ganged together and are designed to the tuning frequency of oscillator is always 455 kilohertz above the tuning frequency of the RF, right? So this is your overview of your AM superheterodyne receiver. So antenna is there, right? That is for detection only. And then RF amplifier is there. Then local oscillator is there, right? And with the help of that only, you can create your image frequency. I always remember the image frequency is fixed 455 kilohertz, only for amplitude modulation. Superheterodyne receiver. Mixer is there, right? So here is a frequency mixer, and then IF amplifier, which will amplify, needs the most of gain and the selectivity, and the detector, which will recovers the the demodulation my original signals, and then amplifier and the loudspeaker, right? So this is your amplitude modulation super heterodyne receiver, one of the most important topics, so you must to undergo with this topic particularly. Now let's talk about the another term, that is noise, right? So what is the effect of noise in amplitude modulation? So suppose this is your modulated signal, right? So whenever we are transmitting any information into the air or a channel, so problem is that at the detector side you will not receive the same information, same message. So what will happen in the way? So definitely in air, whenever your message is traveling, na, it may recombine with the some noise, and the your information may become some the like this jig. So the level of the noise may not be much more high, but still there will be the some deviation in your original signal. So if deviation is there, then it's maybe the difficult to detect the masses, the information from the demodulated signal, right? So that is why we have to study the effect of the noise in amplitude modulation. So what type of the noise? So primarily the additive noise. So it's directly to the signal amplitude, most common in amplitude modulation receiver, right? Directly you may have to. Impulsive noise, that is a short duration, high amplitude spikes, so several distortions. So these are the noise. Additive white Gaussian noise is also one of the famous, the noise only. Okay, why AM is more noise sensitive? And of course, amplitude modulation is the most affected by the noise. What is the reason behind it? Because of the amplitude, right? So information is in signal amplitude. That is the problem. If the information is in frequency, na, then it may not be that much problem, right? Noise also primarily affects amplitude, right? Because that is why envelope detector cannot distinguish the whether is this message or the the noise. So that is the problem, right? So whenever amplitude detector is there, amplitude like since because of the envelope detector, which will detect your message information from the envelope in the demodulation side, which will detect the variation in amplitude only. And since you have already added the some noise, so you know the level of the modulated signal may go up and down because of the noise. So envelope definitely may not be as per the the original message signal. So that is the challenge. And the noise reduction technique in AM, how can we avoid? So increase modulation index, then RF and IF filtering, then automatic gain control, limiters, use of SSB instead of the AM. So these are the way, that is how can we reduce or suppress this effect. So DSBSC, definitely noise immunity is very much poor. DSBSC little bit lesser. Why? Because it may not have the the less suppressed carrier is not present. That's why SSB may be the excellent, because you are going to send the information which have the only particular type of information. So only single sideband, that is either it may have the upper or lower sideband, so it have the advantage. Frequency modulation is extremely good, right? Because uh, there is no frequency, there is no amplitude at all. So whenever it will comes amplitude, your noise will be very high, and whenever it will comes to frequency, then in that case you're definitely the noise will be less in different frequencies. So always frequency modulation is better in terms of noise. Now let's talk few things about the characteristic and the functions of the noise. So major thing is that the communication receiver is a device that receives or selects and amplifies and demodulates the desired signal from many incoming signal and noise, and then delivers the original information to the user. This is the objective, right? So what is the objective? Your receiver receive the signal, selects the signal, amplifies, demodulate, and give the original signal to you, right? So what are the objectives? So like first function, if you will say, signal reception, signal selection, tuning, amplification, conversion, demodulation, and then amplifier. These are the functions. And what is the characteristics? Always the signal reception sensitivity should be very high. Signal selection, your selectivity should be high. Then amplification fidelity should be so high, right? And signal to noise ratio should also be good. Stability is also required. Noise figure should also be also good, right? So these are the major characteristics should have inside your detector or the receiver. Some more key points: function of the receiver, you can check it here: signal reception, amplification, and all those. And characteristic, your sensitivity should be good, selectivity, right? The ability to separate the desired signal from the nearby frequencies, fidelity, your faithfulness on or whether original signal reproduced or not. Signal to noise ratio of noise power to the the noise signal power to the noise power. So high SNR is always required. Okay, so that's all in this session. In the another session we will continue to talk about the FM super heterodyne receivers. Thank you to join the sessions. If you have any another doubts, you may drop your comments. Thank you.